When a laptop, phone, or server joins a network, it needs more than a cable or Wi-Fi signal. It needs an IP address, subnet mask, default gateway, and usually DNS servers. Entering those settings by hand on every device would be slow, inconsistent, and difficult to manage. The Dynamic Host Configuration Protocol, or DHCP, automates that work. In this lesson, we will follow one client from no address to a complete, usable network configuration. DHCP uses a client-server model. The client is the device asking for configuration, and the server manages a pool of addresses called a scope. DHCP normally uses UDP port 68 on the client and port 67 on the server. At first, the client does not know its own address or the server's address, so the conversation begins with broadcasts. The core exchange has 4 messages: discover, offer, request, and acknowledge. Together, they form DORA. Step 1 is discover. The client sends a DHCP discover message to find available servers. Because it has no usable IP address yet, it sends from 0.0.0.0 to the local broadcast address, 255.255.255.255. The message includes information that identifies the client, such as its hardware address or client identifier, plus a list of options it would like to receive. Every DHCP server that can hear or receive this request may respond. Step 2 is offer. A DHCP server selects an available address from the correct scope and sends a DHCP offer. The offer can include the proposed IP address, subnet mask, default gateway, DNS servers, and lease duration. On a network with more than one DHCP server, the client may receive multiple offers. An offer is a proposal, not the final assignment. The server temporarily holds that address while the client decides which offer to accept. Step 3 is request. The client broadcasts a DHCP request that identifies the offer it selected and the address it wants. Broadcasting matters because every server that made an offer can see the decision. The chosen server continues the assignment while the other servers return their proposed addresses to their available pools. During a normal initial lease, the request includes both the requested IP address and a server identifier. The client still does not treat the address as fully approved. Step 4 is acknowledge. The selected server commits the lease and sends a DHCP acknowledge, often shortened to DHCP ACK. The client applies the address and options and may perform conflict detection before using the address. If the server cannot approve the request, it can send a negative acknowledgement, or NAK, which forces the client to begin again. With a successful ACK, DORA is complete. Discover, offer, request, acknowledge. The device can now communicate on the network. A DHCP address is normally leased, not owned forever. Halfway through the lease, at the T1 timer, the client usually unicasts a request to the server that issued it, asking to renew. If that server does not answer, the client reaches the T2 timer, commonly 7/8 of the lease, and broadcasts a rebinding request to any available DHCP server. If the lease expires without renewal, the client must stop using the address and restart discovery. A client may also send release when it leaves, but it is not required to do so. The server's configuration determines what clients receive. A scope defines a subnet and its dynamic address pool. Exclusions keep specific addresses out of that pool. Options deliver supporting values such as the default gateway, DNS servers, domain name, and time servers. A reservation maps a known client identifier to a predictable address, while still letting DHCP deliver the rest of the configuration. Reservations are useful for printers, appliances, and other devices that need consistency without manual settings. Good scope design prevents overlap and keeps enough free addresses available. Broadcasts normally stay inside one local subnet, but enterprises often centralize DHCP servers. A DHCP relay solves that problem. A router or layer 3 switch receives the client's broadcast, adds information identifying the client subnet, and forwards the request to a configured server as a routed packet. The server uses that relay information to choose the correct scope. Its reply returns through the relay to the client. On many network platforms, this feature is configured with an IP helper address. Without the correct relay, clients on remote VLANs never reach the server. When DHCP fails, troubleshoot the path in order. Confirm the client has link and belongs to the correct VLAN. Look for a discover. Then verify the relay configuration, server reachability, and an available address in the correct scope. If an offer arrives but configuration is wrong, inspect the options. If requests are rejected, check conflicts, reservations, policies, and stale leases. Packet captures make the DORA sequence visible. The complete process is client, discover, offer, request, acknowledge, then renewal. DHCP tells a device how to join the network. DNS helps it find services, and IPAM helps operators keep the address plan under control.